Okay, hi, good morning, good afternoon, good evening, everyone. So today is our final class. So today we'll discuss about what is OpenSSL, what is the use of OpenSSL, and then I'll show you the multiple way of deploying. I think OpenSSL comes as a built-in package in Kali Linux. That's something I have tried in Kali Linux. I don't know about Ubuntu. When you're doing a lab, even I would suggest use Kali Linux because you have your Wireshark and you can do you have a built-in tools. So you can make use of Kali Linux for it. So it has a built-in Wireshark, it has a built-in OpenSSL tool. So I'll also show you if you don't have it, you can also use your free AWS account where you can spin up your Ubuntu. There you can do your OpenSSL testing. That also helps you to have a foundational understanding of how you build your AWS and simultaneously you can learn your SSL. That's my recommendation. That's a free account. You can create your free account. I think for 1 year access, so you can play with AWS and simultaneously you can practice your OpenSSL there. On top of that, we will do an use case. We will see how the SSL decryption profile should be created in the Palo Alto, right? And then we'll take a capture, right? That is a broken TLS connection. I will walk you through those PCAPs and how do we find those kind of problem, right? If you, even if you don't have any explicit error in the Wireshark, but still, how do you find it's a problem with your TLS? That happened to me many times. Sometimes you don't see that explicitly. It's because of a certificate issue, or it could be something else, right? So if your TLS connection is not happening, there will be multiple reasons. Example, your certificate may be corrupted. They may be using a wrong key. So multiple factors. But just by looking into the use case and looking into the Wireshark, right, you see your TLS handshake successful, but there is a reset from the client connection, and we'll see who resets the connection and how it is happening and how in that particular situation how we can find a problem. Yeah, that's something we have in the list today. And then finally, we will talk about a little about voice, not much, and how Wireshark can also decode and how we can inspect the packet, voice packets in Wireshark. A little voice stuff, the final, because I mean, I think one of the students he suggested to you know do a little training on voice. So that's something we have for today. So for that, let me quickly share my screen. One second. So let me log into the jump box. So I'll give you a little background about this OpenSSL. So when you maybe you guys have created multiple CSR, but why we want to learn OpenSSL? I'll give you a little background about that. So OpenSSL tool, it's a free, what is it? It's a free application where you can learn how to create your RSA keys, not only RSA, your elliptical curve key, EC keys, how this is created, right? Uh, I mean, it was a mystery for me when to understand how this private key and public keys are created, how the certificate is handling this public key and private key, and since we are all working for TLS troubleshooting, if you understand at a very deep level of how this private key and public keys are created, so that really helps for your troubleshooting. Yeah, because we know the certificate, but I feel like when I started, I don't know what is the certificate standard, and we know what is private key and public key, but how this public key and private key is created and what is encryption. We know what is encryption, but when you exactly apply the encryption algorithm, something like AES 256, so when you apply an encryption to a key, how this is created. So how to create a public key, how to create a private key, how this is exchanged. So this this helps you to troubleshoot better. Not better. It helps you to figure out where the problem is, right? We create a CSR. We know that, so we all doing it for ages. We are doing it as a CSR, but I think how this exactly the how this public key is created when we are doing something, right? When we are doing something, we just create a CSR and we'll hand over to the server team, whomsoever is handling it. But we don't think about how this is exactly created. So we should know how this public key and private key is created, how this algorithm works together. So for that, your OpenSSL helps a lot to understand this. So when you create a key, right? When you create a certificate, what are the three components? First, we will create a CSR, right? Then you create your private key. Then you will give this, you don't give your public private key to anyone else. You will keep it safe, right? And you will give only your CSR to your CA, certificate authority. Example here it is GoDaddy, right? He will sign your certificate. Along with the certificate, you get your public key. Since we are not doing anything with this, all we are doing is we create a private key, we create a CSR, and we are giving the CSR to the certificate authority. You get your certificate signed, and you will get a certificate for it, right? So all you're giving is a CSR, and you will get a certificate. And when you are installing your certificate, you will be mapping your private key with that. But what is happening inside? This is the steps we do. But when we are troubleshooting, right? When you're troubleshooting, somebody is giving you a certificate. Example, your device. I have seen. I think Netscaler we had a problem with a dev format. Whereas if it supports only the .pim or .crt format, how do you change? How do you convert your format, your certificate format from DER to PERM format or from PEM to CRT format, how this conversion can be done. So you can play with this. OpenSSL is very powerful. There you can learn about everything. So you'll learn about what is the certificate type. So this helps you. You don't want to depend on the other team to do this when you have a problem. When you want to extract your public key and private key, I will show you how to extract the public key and private key, how to extract your public and private key, all this. I'll walk you through the practical session, but this is the background about that. So we create a CSR, we create a private key, we hand over the CSR to the certificate authority. It will get it signed from the public CA, so that the public root CA cert is installed in most of the computers, so it's going to trust your certificate. It's not that you can go to every PC and say, I am a I'm the legitimate user, you can trust me. No, nobody can do it. So it is someone who is who is globally who is governing everyone, and if he signs and stamps your certificate, so that all the client PC can trust, because all this operating system that comes with built-in root certificates, and also your Windows have this certificate authority store where you have all your root certificate. We know that, right? So here, generally what happens if you create your certificate, when we say self-signed certificate, there are two options, right? Self-signed certificate, that's something we use to for all most of your HTTPS connection, because that is purely used internally. So nobody wants to trust your certificate. So you create your certificate, and you will be your certificate authority for it. You are going to sign this cert, but you get an warning, right? This site is not secure because it doesn't have the root certificate in the certificate authority store. So this is the very basic. We know this. But here with OpenSSL, what we are going to learn today is that how we can create a private key, how it is created. You can see the algorithm, how it is created, what is inside the private key. But it's an encrypted, but you can see private key and how this public key is created, how this is encrypted. So how if you want to extract your public key from the private key, how to do an extraction. How to see the content of the key, to view your certificate, to view your key and everything. We will do that. So as I said, if you want to do an OpenSSL, there is three way you can do it. The best way is, I would suggest, it's Linux or Ubuntu, or you can use, as I said, you can do your AWS, and then you can run your Linux box there, and you can practice your OpenSSL. This is a freeware, as I said. It's a bonus video today. I mean, I'll just show you how this AWS account is created, and a quick walkthrough about the AWS and how you can spin up your Linux. I'll show you how to do that. You guys can try that if you want to practice your AWS, a basic AWS, and your OpenSSL. And there is an option to do it in your Windows, right? But that's something we are not going to cover about this Windows. We are going to cover only the Linux part of OpenSSL. So this is the tool. So with OpenSSL, you can also you can run the certificate authority service. Yep, you can make your OpenSSL as your certificate authority, so you can sign your certificate. That is also possible. I'll give you a cheat sheet for you so you can practice that, right? So but the base, the foundational, what is the essential commands and the essential, how to say that, the essential parameters of OpenSSL is something we are going to cover today. So let me open my agenda box for it. So this is the tool. It's all purely a command based. You have every, you have all the options here, and you have a proper description and how to do that. And also I will walk you through how to do that step by step. We're not going to cover everything. As I said, the essential what is needed to troubleshoot the TLS. That's something we are going to cover today. So let me open this. Palo Alto. So when you open the what is it, the Kali Linux, as I said, right? You don't want to do anything else. You can check that your OpenSSL it works on your Kali Linux. If you give OpenSSL tab, yeah, so you'll get your OpenSSL. So I didn't do anything. It is built in inside the Kali Linux. So you can make use of this OpenSSL tool in the Kali Linux. Yeah. So first, let me walk you through the what we are going to do today, right? So we are going to create an RSA key with encryption, and also we are going to create a private key and public key, right? And we are going to verify this, and I'm going to explain every step, how to see that in the text format and how to exclude the PEM format and what is modulus and exponent. I'll walk you through everything. Yeah. So to do that, the command is OpenSSL. It means that you're running OpenSSL. Gen RSA stands for you're going to generate an RSA key, and the output should be key2.pem. You can give any name for this. And if you attach your encryption, it's going to encrypt. So we are using AES 128, and the encryption strength is 4096. It's a key size. The higher the key size is, better is your encryption. There's also we have to think about the CPU. So it is a CPU intense task, but because for every encryption decryption, if your key length is higher, it takes more time, and also it is a CPU intense task. So when you're practicing it, I would suggest you to use a very minimum key size. Don't go with a higher key size. Just try with the minimum key size, right? And we are going to use a cat out command to view and to see what is inside the key. So now let's see here. This particular command is I'm going to create an RSA key with encryption. If you don't want to create an encryption, you can get rid of these two because this defines your encryption. So if you don't want to define your encryption, so you can get rid of this command. You don't want to define your encryption. So let's create a new key with this. Yeah. So I'm going to copy this command. So let me copy that. So instead of this, I'm going to create a new key. So as I said, I'm telling OpenSSL generate RSA key, and the output, my key file should be the name, the user defined name, what I am giving here. And this is my encryption, and this is my key size. So I'm going to give this as a key 3 for consistency. What if I'm going to create this key without encryption? So I want this to be in PEM format. As I said, you have two formats and multiple formats, but most widely are PEM and DEV format. So it is generating a private key, right? This is without encryption. And if I want to see what is inside, if I want to do it, I want to do a cat out command, cat to see in Linux, copy this, paste this. So you can see there is no encryption header here. So you created a private key. This is just a hash, not encryption. That is the difference, right? For encryption and decryption, you need the key to open it, but this is just a hash. We are not doing any encryption here. But say, for example, if I want to create a key with encryption, so I'm going to say key3 with encryption, ENC. Let me give a name, hyphen here, with encryption. I'm going to give the command AES1024. There is a syntax error here. I have to give hyphen there. You can have your scripts side by side. We don't want to master the syntax here. The whole logic is we have to understand the concept. Yeah. So I'm giving with encryption now. That is without encryption. Now I'm giving this with encryption. If I press enter, it is creating a key with encryption. But if you want to do with encryption, you have to give a passphrase. So I am going to give this passphrase as key3 to remember. Key3, enter. I want to type it again. Key3, all capital same. It is done. So if I do a cat now, this is with encryption. Yeah, that is without encryption. How do I differentiate with encryption and without encryption? Dot them. So you can see this additional header, right? So you can compare your output. This is encrypted. This key is encrypted. It is using AES-128 CBC. So this is how you encrypt your file, and this is recommended. This is how you create your private key. So if you remember, when you do a private key, you always give your passphrase. So that over the email, if you send, if somebody wants to open this particular private key, he should know the passphrase. If he doesn't know the passphrase, he can't open it. Right? If you remember, when we created the key, it was asking for the passphrase when we created, right? So I gave this passphrase here. So without the passphrase, you can't open this file. So when you transfer this file, especially when you get your file, or if you want to send this file to someone over the email, it is always recommended to create a key with encryption. Most of the time we are doing that. We are not doing without encryption. So sorry for this keep popping in because of some error here. I tried to stop it, but still it is coming. Bear with me. So that is how you can create your private key with encryption and without encryption. And you can see this, and you can't see anything inside. So for now, let me give a quick Q&A session for this, and let me know if you have any questions, you can ask me. So I'll give a quick unmute permission. Yeah, I gave an unmute permission for everyone. So you can ask your questions if you have any questions. Asad, Meeraj, Nilesh, Santosh, Vital. If you have any questions, you can ask me.
Yeah, hi Praveen.
Yeah, yes, Meeraj. Meeraj, right? Who's talking? You guys can't talk. Yes, Meeraj, you said something.
Yeah, can you hear me?
Yeah, yeah, now I can hear you. Yeah.
Yeah. So normally we create the CSR from the load balancer.
Yeah.
When we create the CSR, so it will not show private key. It will just give us the CSR value. So
Is it
in that
what
case,
load what load balancer you're using?
like F5.
But generally, you have to map your private key when you are installing the certificate, right? When you create a CSR and give it to them, and there should be an option to create a private key for you, right?
No, actually it is not. While creating the CSR, it will not ask and it will not show also.
No, no,
Only
not
it
for
will show.
no, no, no. You are right. Not for CSR, but you have to create your private key to map your with your certificate, right?
Yeah. So what will
Isn't it?
happen when
Mm-hmm.
we get the certificate?
Mm-hmm.
So when we upload the certificate, then it will show private key and the certificate both. But
Correct,
while
correct.
creating a CSR, it will not show.
No, no, no. I'm not telling while creating the CSR. I'm telling the process. I mean, you have to create your CSR plus your private
Mhm.
key separately. So once you give the CSR to the CA, he will sign and give it to you. And then when you are installing your certificate, you have to map your private key with your certificate for installation, right? Otherwise, it won't work. Yeah, that's a mandatory
So I
thing.
think yeah. So FI will do automatically this one through a
But
browser.
is it? But how do you map your private key? You don't map your private key with your certificate when you're installing it.
Yeah. So when we create the CSR, we give CSR.
Okay.
Then they will provide us the certificate. So we'll
Okay.
upload the certificate. So once we upload the certificate, then we will get both on the same. We'll not see the
Private key.
CSR is separate. Yeah, then we'll see private key as well as certificate both together.
But from where your private key you will get your private key when you have an option to attach with your cert. How do you do that?
We will see only after we upload the certificate. Before that, we will just see only
Yeah,
CSR.
that's I got it, Meeraj. But where you will get your private key at the time when you want to install? At that time when you're installing your cert, you have you it's a mandatory option there to select your private key, right? To pick your private key to attach to the cert.
Yes, yes,
Then
yes. That's
how?
it.
Yeah, yeah.
Yeah.
But how do you get that private key? Is it something you have to create, right?
Actually, on load balancer, we will not create separately
Mm-hmm.
as a private key. We
Mm-hmm.
just create the CSR
Okay.
and we'll provide the CSR. Then we will get the certificate.
Okay.
When we upload that certificate to the
Mm-hmm.
CSR,
Okay.
then we will get. Then it will show key as well as certificate. I mean, private key and the
Oh,
public key both.
oh, you mean to say it extracts a private key for you and give it to you when you're installing it?
Yes, yes, yes. Yeah.
Mm-hmm.
So maybe it is a background process. It will
Mm-hmm.
not show to us. What
But
we see only
okay.
the CSR.
Mm-hmm. Got you. But this is how it is created. This is how your private key is created. Generally in Netscaler, what happens when we are creating a CSR? We will create a CSR and also we'll create the key. And the
Uh-huh.
key, it is saved locally in the Netscaler. So once we got the certificate, so when you are
Mhm.
installing the certificate, it will ask you three options. Your certificate, then your private key, then your passphrase. I shown you, right? When you are doing an encryption, you are giving the passphrase. I have to give the same passphrase when I am attaching my private key with cert. Maybe in your case that works a little different. I don't know how it works there,
Yeah,
but
yeah, yeah,
but this is
yeah, yeah.
how in the generally this is how it works. I mean, even in Windows when they are installing it, they have to attach the private key. Without the private key and passphrase, they can't install the
Mhm.
certificate. Say for example, you're creating a CSR from a Windows machine, and it can be any server. So when they are installing it, they need the private key. Only then they can install the cert that particular in the particular server. That's how it works there. So
Yeah,
this
yeah.
is the
Okay.
whole process. I mean, creating an RSA key. is different. The same logic applies when you're doing an IP sector, right? When you have your encryption, when you select your encryption, your what is that? Mm, your defilement group, when you define those keys are used like that. The logic is different, but the process remains the same. This is how it is encrypted. A key is encrypted. Yeah. So
Yeah, yeah,
now
okay.
now
Got it. Thank
inside
you.
now yeah yeah now inside this key you got your public and private, and I'll show you how to extract that public and private from this now, and how
Okay.
this public and private keys are created. Yeah. Okay, fine. Do you have any other questions, guys? Asad, Santosh, Vital. Give you 2 more minutes. If there is no questions, then we will jump back. Asad, you have any questions, Asad?
Yes, sir.
Yeah,
So
yeah.
could you please show us in the Palo Alto device also how? So we know how to generate I have the also the same question. We know how to generate the CSR, but while
Okay.
generating the CSR, it does not ask for the private key. But when we are importing, it
Mm-hmm.
is also asked for the private key. So
Is it? 1 second here. I think we'll go back to this. You see, I don't know about this process here. Certificate I have downloaded here. So how to patch private key? Need to generate the private key to use with OpenSSL. You can generate it. I don't know how you guys are creating that. Maybe I have to research on this and I'll ping you in the chat. I don't know how it is used, but if you generally see in the Netscaler private.
So basically, actually, the process, Praveen, look like when we create any, if we, when we want to create any cert, that time we have to create a CSR. Okay, while the
Mm-hmm.
CSR, that means when we generate the CSR, so that time that CSR automatically bind the private key. Okay,
Mm-hmm.
and when we once the CSR generate, and after the export that file from the device. Okay, so that time also you can see that private key with the
Mm-hmm.
CSR. Second thing, when you click the CSR, whatever you generate the CSR on the device, so it will show the two, three options. Okay, the first tab, the upload related means the cert related information. The
Mm-hmm.
second tab, it is showing the private key related information. Similar for the FI also. Okay,
Mm-hmm.
when you create any CSR, so both CSR means private key and the CSR related information both are showing.
Mm-hmm.
Okay, so the
Okay.
automatically process happen background when you
Okay.
create any CSR.
Okay. Okay, got you. So, Nilesh and everyone, if you look at this, even when we are creating the CSR, right? So when we create a CSR, this is a CSR file, and this is a separate key file. We have to attach like this. What is the hashing you're using, your all the other parameters of your CSR. And along with that, when you are creating a CSR, you have to define your key file. We will be creating a key file separately like this. In the top, you can see, create your RSA key. This is something we did in the OpenSSL. We created this in the CLI. So you have to define your algorithm, your encryption. Here the encryption is AES and the key format is PEM format. And this is the key size. So I don't know, maybe that is a bit different there. If the private key is encrypted, you should use your passphrase for it. The same thing we did there. So I will research that and let you know how it is created. You guys also can research that. But definitely without the private key, you can't install your certificate, because the person who is the owner of the certificate always has the private key and it is not given to anyone else. Without the private key, what the what do you say, the receiver, or maybe the your remote peer who is trying to establish a connection, SSL connection with you, if he doesn't have a public, if he is encrypting the data with a public key, because you will hand over your public key to everyone, whoever wants to establish a connection with you, if you own a certificate and you are the SSL server for it. And if he doesn't have, if he is sending something with the encrypted, and if he's sending back something to you, to decrypt the data, you need that private key with you. That's the whole point. So that's why we are creating a private key here. The logic remains the same. Maybe the implementation part is a bit different, but the whole point is you need your private key, your public key, then your CSR and your certificate. All these are essential elements. Without your CSR, you can't get your cert. So once you get your cert, you should have your private key and you will hand over your public key to the clients who tries to connect with you. So coming back to the lesson. So we have seen how to, one minute, let me go back to the next box. So we have seen how to create a private key. And I want to show you how to differentiate the private key and public key here, how the public key is created when you create your key. So whenever you're creating a key, this is, we are creating an RSA key, right? So if you want to see the content of it in the text format, so you have to use a command OpenSSL RSA key, and the input key is the feeding. You have to feed your key. The key there we are using key3.pen, and it should be, you should you should view your content in the text format. So that's the whole meaning of this. So let's copy this command and let's see how it looks in the text format. What are the contents inside that? So it is, first we have to give ls. So we created this key3 with encryption PEM. So I'm going to replace this with this file name. I am doing something wrong with the command. It is key3.pem, right? Oh my god, I screwed up with commands here. So I have to give the passphrase for it to see the content of it. Key3, key3. So earlier we didn't see this coefficient value, exponent value, the prime values. This is used to create your public key. So once if you see this is a public exponent. And if you go back to this command line, so your modulus and the exponent values combines together, that gives you a public key. So when you are creating your private key, right? So this what happens, right? So you want to go a little deep about this. So when you have your certificate, when you got your certificate, you should see something like your public key on it, but that is encrypted. Encrypted with what? The same key what we used, that is encrypted using AES 128. We are encrypting this and we are sending this certificate back to them. They have this public key, but how this is created? This is how it is created. When you're creating your private key, that also creates your public key. That is the component I told you, right? So inside the private key, you have your exponent and module that combines together, that goes through the mathematical operation, and that creates your public key. So go back to this, go back to Windows, and let's see this example. Connection is secure. Want more information? And Meeraj or someone, I mean, long back they asked, this connection is encrypted. See, this is encrypted using TLS 1.3. Right, you have to go for in the Linux, you have this option. If you click on this pad icon, you can see what is the algorithm they used, the other end, to give view certificate. One second, actually, I missed that part. So I have to click on the pad icon. I want to go for more information. There you will see this is a TLS connection, and it is using, they are using AES encryption, and they are using the SHA hashing, and this is using TLS 1.3 key encryption hash. So you can see that how exactly the communication is happening, and this is 128-bit key. And if you view your certificate, a bit different. How does it shows in Windows? One second, let me check this. Here, you can see your public key here, right? There, I don't know, in Unix it shows different. So this is your certificate, it's hashed, and you have your public key. So my computer is encrypting, decrypting based on this public key, right? And this public key, right? Whatever encryption I'm doing, only the server which owns this private key. Because when you create a private key, if you have seen, we are also there is an additional component. Only the person who holds the private key has the public key. Even somebody is trying to hack this, if somebody is trying to get this key, he can't do anything with that, because he is creating the public and private key and he is giving to you. Only the person who has the private key can decrypt it. So he can't do encryption and decryption with this private key. Yeah, because the key material, whatever we did for this whole process, is something happened only with the private key. The person who holds the private key has the complete control of public key and private key together. That's why the private key is so important. That's how it is created. Now let's see how do we extract the public key and private key from that. So here we are using a different key. It is key3 with encryption.pem, and I am telling that I am feeding a key OpenSSL RSA. In the input is the key file name, and the pub out means it will take out, extract your public key, and you can give any name for it. This is the output of the file. So it is telling that you extract the public key out of this, and the output should be the name, whatever you want to give, you can give it to extract your public key. But to extract your public key, you need your modulus and exponent, both parameters. Yeah, if you look at this, this is your exponent, and if you scroll up, see, this is your modulus. So with these two values, right, with your modulus as well as with your exponent, public exponent, it creates a public key for us. So we are not, we don't want to go this deep level. This just, I am giving a complete insight, a deep understanding of how this public key is created from a private key. So if you go back, and copy this command, the syntax is bigger. Let's copy this command, go back there. We give an ls to see the files. I'm going to paste this command. So I'm telling OpenSSL RSA, the input key file is, this should be the valid key we should have inside first. This is the key we created. Pub out, and I am telling this. This is key3 pub, public key. So I have to give my passphrase, same key3, all caps. So if I give ls, you can see key3 pub.pem. So now if I do a cat out to this particular key, so if you see this, this is a public key, end of your public key. It's completely encrypted. So now we have successfully extracted your public key from the private key. If you look at this, this has your public key and private key. To create your public key, you need your exponent and module. So with the exponent and module value, right, you see your public key here. This is how you can extract your public key. If somebody is giving a private key, and if you want to extract the public key, usually what happens, they will create a certificate. And if you want to extract your private key from that, I have experienced that. That's when I started using this OpenSSL. So I had a problem. They had something like a DIR format. I have to convert this back to the PEM format, and from the PEM format, I have to extract the private key. And we did that. So we don't want to depend on any other team to do this. This extraction process and everything, we can do it. And also this helps us to understand how this public key and private key works and how to extract, right? This is an additional skill you can develop when you're doing your troubleshooting. So this is how your public key and private keys are created, and you can see that using the cat out. And also, if you want to do your if you want to see the supported algorithms for your public key and the cipher suites, you can give this command in your OpenSSL. OpenSSL list public key algorithms, supported public key algorithms. You can see all this. We are using PEM with RSA. You have a DSA, you have Diffie-Hellman, lot of algorithms you have. So you can play around with this, and also I will give you this cheat sheet. So this helps you to work on better, right? So this is a FAR minimum, what you want to really understand how this private key and public key is created. So now we understand how this encryption decryption happens and what algorithm is used. So when you're troubleshooting, it will give more insight about that. So now coming back to this Palo Alto decryption, we'll take a PCAP and I'll show you that. So we will talk about how this encryption decryption profile should be, how it will be created in your Palo Alto. Before that, let's take this capture and let's analyze where is the problem. Yeah. So for that, let me open the Wireshark on it. Okay, this is already we captured this packet. We will do that one more time. So okay, so this is a traffic. I will do it. We'll do a live capture and see. So let me go to application. Where is that? This usual application, internet, and my Wireshark. What's happening? So I have a Wireshark open here. Go to the top. There is my Ethernet 0. So now let's go back to the application, go to Firefox. Is it different, Firefox? Okay, so now let me generate some traffic here. So now in the topology, what happens here? This guy is 30002, right? 30002, it's trying to connect to 30001. So here I am doing, since I'm doing an SSL decryption, I'll okay, there are a few guys, they may not from the security background, so I'll give a little background about this SSL decryption in Palo Alto. So this is your Palo Alto. So we are using a forward proxy. So that this is something like man in middle, MIM. So this is the client, and this is the server. So generally how your TLS handshake happens, you should have the server certificate here on the client. Example, the server is server X. So I should have this, whatever the certificate the server X has, it should be signed by a CA. I should have this root CA in my computer of server X. Example, in this case, it is example, take same example, GoDaddy. He signed this cert. So I inside my root CA, this client, I should have this GoDaddy. GoDaddy root cert. I should have. But instead, what I did, I have enabled the forward proxy and I enabled the SSL decryption profile here. For this SSL decryption profile, I should create a self-signed certificate. And now I am blocking the unknown root CA in the policy, in my decryption policy. So whatever I see the unknown root CA, that is blocked. Block the unknown root CA here. So this is how the profile is created. So now I am trying to do a capture, packet capture. So I am trying to connect to, for this is applied for all my, what is it, in the decryption profile, I am telling that the traffic coming from inside going to outside zone. Block the unknown root CA. So now, since this is a self-signed certificate, my PC doesn't have the root CA of my Palo Alto because I did a self-signed certificate. So I need the same root CA cert here. Otherwise, it's not going to trust. So this is how we did. So we created a cert and we created the forward proxy here. So we are decrypting the traffic. Now this client is trying to establish a connection with Palo Alto, and let's see what happens there. What happened here? I think one second here. Why this has changed? Cannot read properties undefined reading status. Was working fine this morning. Oh, it works still, let's say, okay. I had a little hiccup with this now. I want to show you that. Okay, let's come back to that. It's fine. So there is some problem with the login there. I don't know, it worked since now. Okay, so when I do a packet capture, right? So when I do a packet capture, so it is that I will see, usually I will see this SSL handshake goes through. I'll erase this and I'll show you this. So I will see the SSL handshake happening there. First thing, and the second thing is I see client hello, then I get the server hello back. So I see the SSL handshake, I see the client hello, I see the server hello, but there is a reset from the Palo Alto. That is, in that case, in our topology, we know that is 30002. So here, this is the Palo Alto, that is 30001. And this is my client PC. It tries to connect 30001. Who will do a reset? The 30001 will do a reset, because this client doesn't have that certificate. But you see your client hello, server hello. I'll try to send a capture after this class, but that's how exactly it works there. So once you create a SSL decryption profile, once it goes for the TLS, that's how the certificate plays a vital role there. So you should understand every component of your certificate. So just by looking at your client hello and server hello, and also if you don't see any kind of error related to your certificate, don't come to a conclusion. If somebody is doing a reset, who resets the connection and why it resets? So you have to look for all the parameters in your certificate. And as I shown you before in the previous classes, if something happens with your encryption, your hash, how do you verify? Now you know that if you expand your options, we discussed this in the previous classes. In the extensions, you can see your TLS supported versions. Most of the time, if the client is proposing the lower TLS version, and if the server just support only the higher version, always look for the higher version. And if the server doesn't support the lower version, it's going to break your TLS connections. So these are all the most wide troubleshooting and most use cases we have for the troubleshooting, and I would say the most common problem we encounter with.